think that's what we mentioned here, 2025B. Yeah, most of this will be the version that you would like to use. If you try to use the VMware or this Linux, actually is going to have the 2020. So this will be quite old, not going to operate the file that we have. You can go through these points, and also that that's something very important. You need to go to the people, and here you find the mini project groups. You need to add yourself to here. Even if you're going to do the work by yourself, you need to be in a group in order to submit your work. What you need to do is, after you installing the MATLAB on your computer, you have to select all the libraries that's available for you with uh, the Simulink. That's how it's going to work. The other way actually to operate the MATLAB is going to be by opening the MATLAB online. And this will give you the same MATLAB, but it's going to be online versions. You don't have to download on your computer. And this will save you something like 26 gigs of your hard disk. So how to use the files? You just go to any of the files. I did this one in the class over the week, but anyway, I'll do it once again. You just click here, and the file now is going to be ready to download. I choose a new folder here called the project folder. I'm going to put it here. That's will be my first file. It's just 30.1 megapascal. Okay, and I will do the same thing with the other file here. Okay, so what's that? I'll download the other file. I'm only going to show you actually today these two files. Okay, then I get to the files are zip filed. So what I'm going to do is I'm going to extract them both. Okay, so extract all. We'll put it here, the same folder. Okay, so now we have the file has been extracted. Now I will go back, do the same thing with the other one. So again, to the pendulum question, extract here, extract. Okay, I have this one now is available for me. So now I extracted both files, and I'm going to show you now the process of take them to the MATLAB, the online MATLAB. So when you go to your website, you click on your account, and this will open the account folder for you. You go here to MATLAB Drive. Okay, and then just simply drag and drop the files to this folder. So you can see that I already had the pendulum one. I did that the last day. I think I did that yesterday. Anyway, I will. Oh no, I did the spool on track last day. I had pendulum, but is that the one actually available on my YouTube channel, which is for Western Sydney Uni. So again, to bring the pipe pendulum to here, just drag and drop, and you will see that the file now is available for work on it here. So we have it somewhere here. Cannot read very well. Yeah, it's here. Oh, I brought this a file. Sorry for that. I'm going to delete this one. Delete it. I should bring the okay. I should bring the extracted file. So no, this I should bring this one. So you saw actually how did I delete the thing? Just highlight it and click delete on your computer, and you will delete the file. Now I have this one is available for me. It's uploading now. Okay. Then it's done. It's taking time. Okay, now it's updated. So now I can find both files available for me, the pipe pendulum and the truck and the spool. These are the two work that we have in the mini project. We have the other two. I will do them in separate video later. So just remember something that here we don't do any programming mainly. We only going to be users for the code. So you'll need to do at least the handwork, and then you're going to do the comparison between your handwork and this one. We need to do that just to show that you know what you're doing. Now I get to open the online MATLAB. There. It's usually going to take some time. Okay, I think that I have some files open from the last week. Anyway, so yeah, so these are my folders. You can see that I do have now the pipe pendulum, and I have the truck and the spool. Yeah. So to open any of these files, I'm going to right-click on the spool on the truck, right-click and open, and now I have all these files. To start your work, usually I don't prefer that you do, well, actually it's not preferring. If you double click on these files, they're not going to work as what's it's meant to be working. So the best way is right click on the file. Usually we're going to start with the start here. As you can see, this is start here, please. Right click and open that file. So now we'll find it open here. It's taking this time. Now that's the first example. So you remember the example we had on the truck that carrying a spool on the back that is going to speed up. So due to the kinematic motion, the body will be rolled out and fall from the back. Also, if you're going to add a brake, this spool will go forward. I think that we saw one of these example during the tutorial sessions, and I'll try to find the exact example and solve it to you step by step in the tutorial session next week. In general, everything actually is being described in this file. So if I'm going to click this one, this will give you to the MATLAB, and it's going to show you all the equations of the motion that we need to work on. Then we're going to have two cases. The first one is going to be no slipping. The second case is going to be a slipping to be determined. So I'm going to go first to that file, just click on it, and it's going to open a new file for you where we're going to have a derivation for the motion equation for the spool over the track. So we have a spool of rolled sheet metal sitting on the back of the truck. The spool is not secured by rope. So when the truck is going to be accelerate forward with the acceleration of the x double dot one, the spool is going to be able to roll back. So the equation we're going to have for the free body diagram, and this will be for the kinetic diagram. The N is the normal force, the FF is the friction force, the theta double dot is the angular acceleration of the spool, which is alpha. The X double dot is the translational acceleration of the spool, which is the A. And the M is the mass, and the IZ is the inertia, moment of inertia for the body. That's the free body diagram and the kinetic diagram. These are the equation we're going to have. I'm not going to explain this one now because we're going to explain it in the class. And then among these two, we're going to have two scenarios. The first one is no slipping scenario. The second one is going to be the slip scenario. Okay, so now the equation actually has been implemented on the MATLAB code here. Okay, and this for the non-slip equation, and this will be for the slipping equation. Usually, if I can find that this one is going to be available for me, I can run it and I can find the result for that. But in general, I get to run the code and see if it's going to work or not. We hadn't changed actually any parameters, so I don't expect that this code is going to be run. Instead of that, we will find that there will be another code will run the things for us, which is going to be task number one. You go to the case of the no slip. So it's a MATLAB code. Okay, this will be the calculation of the theta double dot, the x double dot, and the friction force. Start with the clear the state. So here we're going to write down a clear. Okay. And if I would like to clear everything, I will write down CLC, of course. So I clean the state so we don't have anything in the workspace. The case study of the part number one, you can change your parameters from here. You can write down whatever number you want, the spool length, the spool radius of the gyration, the spool inertia about the z-axis, the spool radius, and the track acceleration. And the g is going to be a constant. And now we're going to have the and we divide the theta acceleration, the linear acceleration, and the friction force. Just brought the equation from there. So continue with that. That's for the slipping case, and the other one is going to be for the non. Sorry, this one is non-slipping case, and this is a slipping case. Okay, so all being implemented, and we just need to check the final state, which is going to be how to run this code. Anyway, this will be the slipping scenario. Okay, once again, we'll just repeat the same analysis, and we put all the parameters here. We can change now that with the slide, sorry. So the 500 kilograms, the maximum K value is going to be 5. The acceleration is going to be anything between 0 to 0.5 meter per second squared to 20 meter per second square. The IZ value has been calculated by using the mass and the K value, or the radius of gyration. And yeah, we continue with that. We have everything has been implemented, and then we're going to run it to find the parameters. The next part is going to be using the Simulink link, and this will be done by opening the PHP model for the spool and the track SLX. So we look in here, and we will find the same file, the baked hot model for the spool and the track SLX. So we're looking for the this one. Right click, taking time, okay, and open this file. Actually, for this one, I can still run it, okay, and it should give me some answers. It's still calculating here, as you can see, and it's going to give me some results. And also, we uploading the Simulink window at the same time. I shouldn't actually replace this one now. Okay, so that will be the Simulink model. Actually, it's containing the parameter that we changed, has been updated in the workspace. The same codes has been built here. Okay, so all the files has been built here, and that will be the model, and that will be the measurements. Okay, if I get to double click on this one, it's going to show me what do we have inside. So that will be the multiple parts. Here we're going to have, if we're going to click on this one, this will join the graphs for me, and I can run it and see the results, but I prefer to run the whole code. So I can either go back or I can close this one and check the Simulink file itself. I shouldn't do that actually. I should just simply go back and see the things. So anyway, it's still loading again. Okay, now that's we have this one here. Okay, now what I'm going to do is I'm going to maximize this one, and I'm going to run it and start to do some calculations here. Just remember that you need to change the parameters. Actually, that's the things, but it's from the top, actually from the bottom, and we just need to see it that way. I'm doing that actually by pressing on the mouse roller and move it downward, and this will show me the things from the side. Actually, you will see that the track has been left, which is here. So I will get it close to this one, and then I can try it once again with a lower speed. change the value from here. Now I'm going to run it. Okay, so actually that's what's happening. So you can see that it's going to roll backward and leave the truck. Okay, so that's one of the things that I would like to show. This is the animation. I'm going to collapse this one. And now I would like to see the results. So you can see that we didn't have any graph. We didn't have anything here. So I'm going to double click on this one once again. Okay, and I'm going to double click first on that one, which should show me the x dot, and the x double dot. So this will be the displacement, this will be the velocity, and this should be the acceleration. You can see that I don't see the whole view, so I can choose whatever I want to do with this graph. So I can use the hand to move the things. I can do something like the zoom in or zoom out. And from here, I can find what will be the maximum displacement we are going to achieve. Something like 17 meters. For the velocity, the maximum will be, let's went up to 26 meters per second. For the acceleration, I cannot see any acceleration here. That's strange. Okay, so let me check. Yeah, that. So the acceleration will be 20 meter per second constant. Okay, so that's by clicking that, I can see everything. Now you can snapshot this one and put it to your report, and you can change your parameter multiple times to find the answer. So that's for the scope one. Let's see the scope G. Double click on that. I'm going to have the x2. I'm going to have the x2 dot and the x2 double dot. And also we can find the theta. The theta is going to be here. Again, I'm going to, I cannot move this one. Okay. So I can, once again, click on this one, and it's going to show me the full parameters. And you can see that that's what's coming to the theta double dot. It's going to be increased to 0.02, and then it's going to be constant. Sorry, it's 0.021, and then it's going to be constant as 0.02. Then it's going to be dropped to 0. And here we have the time, and the x dot, which is the displacement double square, which is going to be the acceleration, also given here. This will be the x dot, the velocity, and this will be the displacement value. Again, I can hide this one. Now, for the things I had, I can either look for them, or you can simply click on this one and choose whatever one I would like to overview. Same thing I can do it with the last one, which is going to be the scope of the friction forces and the slip state. Okay, again, I'm going to click on this one. Okay, so this will show me actually, well, actually, where's the description of these lines? Okay, that will be normal force, friction force is slipping, and this will be the x2 value. Okay, so this is the case of no slip, and this is case of the slipping. Again, these are some of the results, but for the numbers, we also can get them um, from here. Actually, I created this one yesterday somewhere. You should show me the answers. Okay, anyway, you can see that. Double click here will show you the scope for the G block to plot to support the dynamics. This one is going to be for the plot for the friction forces acting on the spool. And yeah, we did that. We did this one. Here we are going to see the measurement tab sheet by clicking on this point. So I'm going to go back to this one. Okay. Up. I should go up. That's measurement tab sheet. That's the model itself. I can now see any result here. But I remember that actually yesterday we saw some of the results and told us what will be the parameters. I don't know if it was this question or the other one. Anyway, so yeah, that's how to use this one. Just remember that this video is not going to be a replacement for um, uh, the tutorial we're going to have with the guest lecturer on Monday. So I would like you to attend this one. Check that, write some notes, and ask the guest lecturer about your questions. I'm going to make another video for the pendulum question.